So last class we have seen plenty of Kubernetes resources, like services. What are the type of services? Like what is cluster IP, node port, load balancer, and external name. And we were seeing some demos in service, and then we moved back to what is ingress. Ingress will be the first entry point of the cluster which receives the traffic based on from the ingress, either by using the domain based or path based routing. So services like traffic is routed to different services. That what we were seeing in the ingress. And then we were seeing what is config maps, what is secrets. Config maps are used to pass the environmental variables, whereas secrets are used to pass some like sensitive values like some DB username or password. Like how we have to create those things like config map and secret, how we have to pass them as a environmental variable inside the pod that we have explored. And then we were seeing what is security account, like by using security account, how the pod is going to access some resources within the cluster as well as outside the cluster. It is handled by the service account. In order for the service account to get those roles, we were creating those roles by using the cluster roles. We will define this application can go and do these operations and all, and then we do cluster role binding. In cluster role binding, if you see cluster role binding, it will have the service account name and the cluster role which we created. So, and then we were at last we were seeing um, the daemon sets. Daemon sets and deployments both are same, but the daemon set will be running at one running with one so single replica in each node. To mostly it is used to run some scripts in the particular node or to scrape some data from the node. That's the use case of daemon sets. So in the last class we were trying to access. We figured out some issues in the Nginx. What happened is like today what I applied here is like in the Nginx configuration I added one more section like TLS toast, and the secret name is equal to Phoenix TLS secret. What I done today is like if you go to the slides back. mm, I told in order for you to have this SSL to run your application, you need SSL certificate, SSL or TLS certificate. Both are right word only. Like in if in order to get that you have to do some CSR report and submit to CA authorities and all. So there is one more way is possible for us to test it. That is we call some self-signed certificate. By using this open SSL commands, we do that. If you have started using some SSL certificate, this open SSL commands, you have to install these commands, this function in your Linux machine or a Windows machine. What is this open SSL? Open SSL is kind of a tool, because the certificate mostly will be like in the base 64 or like with like which will be completely like masked one. You cannot read it like the plain text. Like it will be like mostly if you see the TLS secrets and key, you see this is like a masked one. You cannot read these things. You cannot read any information here. This open SSL commands are used to process these certificates or read the certificate. There are different commands are available in the open SSL. So okay, so what I did is like by using this open SSL command, open SSL request X509, that means the SSL certificate type, and then notes like it should be expiry in like 365 days, and that encryption type is RSA 20848. I first class I told when we were creating AWS key, mostly the encryption type we will use is like RSA. We mentioned RSA, and I want from this the key outlet will be TLS key and then TLS secret, and then I'm giving my domain name here. Subject is equal to phoenix-demo.com. This is my domain name. So you can just do some ChatGPT or you can check about OpenSSL. So these commands are used to get your self-centered. When I run this command, this OpenSSL, this complete command in the bash, what happened? Let me run once again if possible. Uh, if you run this one, uh, what will happen is like a TLS certificate and the TLS key is get created here. How I know it's come in this TLS certificate in the key format? I'm mentioning the file name here. my key file should be like tls.key and the out file is tls.key. So by using this, we will create a secret, TLS secret. Okay, normal secret is different, TLS secret is different. When you specifically create the secret, you just run the kubectl create secret, and then you give some name and you give some um, like the key value pair. But when you create TLS certificate, this is how the command is going to be look. kubectl create secret TLS, and for the TLS secret you give name as phoenix hyphen TLS secret, and then I'm just mentioning the certificate and key file directory where it actually presents in my system. I just give that, and then I create it. Here it's already created, that's why it's throwing in error. If you see kubectl get secrets. Hmm. You see this DB secret, this which is of type of opaque. This is the opaque fragments. If it is like so many sensitive values, you have to mask that like key value per that. For that time, you will be using the type as opaque. Now the secret type will be TLS because I am creating this secret only for SSL. Then you should mention the type as TLS. That's the reference. Now you will see the secret is created. In my Ingress configuration, I have a separate section for this TLS certificate and what is my host name and all. Okay. Then after you create, see this path after whatever the Phoenix domain after the domain name phoenix-demo.com. If I put slash, it should redirect to the service. What service? nginx-service, where we created in the service.yaml file. We actually created this one. Okay. You just focus only on this ingress file now. So this how mostly organizations will be running the nginx in the local. I tried to execute the same thing, still it's not working for me. But I just yesterday I was not able to create the TLS secrets. Because my laptop had some issues. And OpenSSL was not installed. So that's the thing. I have installed it and I'm showing you the demo how the ingress configuration in real-time organizations is going to look like. So this is how it will going to look, and they will have different paths. Okay, in like like as latex, if it is slash app one or some slash web, go to the service, or if it's slash API something, go to the service. This how the entire ingress is going to be look in the real time. Okay, so today, we have covered so far last lot of topics, and similar to cluster role and cluster role binding, we were seeing role and role binding. Cluster role and cluster role bindings are used to provide permissions for a pod using the service account. Role and role binding are used to provide for users like you and me, or like for your team. In order for your team to have some permissions in the cluster, we use something called role and role binding. So I hope I have covered most of the resources now. So when we were like running this Kubernetes, when you were running like this Docker pods, what we thought we was telling the pods are ephemeral. What is that pod or ephemeral means? If the pod goes down and comes back, it will not store those volumes. Okay, whatever the file generated during the runtime, it will not be present in the pod. So similar to that, like in Kubernetes also, all the pods are ephemeral. If the whatever in the runtime, if a pod generates some data or some files, it will be get lost if the pod gets restarts. So that's the need. We are using this persistent volumes and persistent volume clients. So let me open my pane. So when we were seeing Docker, what we were thinking when we in a Docker container is running, so if it is generating some files in some particular folder, like consider it is generating some files in slash tmp, okay, in slash tmp file, it is this Docker container is generating files. What we thought we were talking some volume mount, right? What will do? It will in any particular directory, like some directory in the physical host, in the physical host of the machine. So we map these two directories. So whatever the file that got produced in the Docker runtime in the temp directory will go to this physical host as well. So if the pod goes down and comes back, then uh, this directory will store the files. So the new pod will have the access to the files which it got generated. So similar to that, we are going to see this persistent volumes and persistent volume claims. PV means persistent volume. This is consider it as a disk. In your laptop, you have a disk, right? We call like 500 GB SSD, like hard drive or hard disk, whatever we call HD or SSD. So this PV is completely an you consider it as like your hard disk. Then what is this PVC? PVC means like persistent volume claims. So we what we do is like if this persistent volume have like 500 GB or something, uh, consider it as 500 GB. I'm going to request like 1 or 2 GB here. That is called persistent volume claims. This persistent volume claims will get attached to the pod. Okay, PV as 500 GB. I'm going to get only 1 GB, which is created, which is like I'm going to create something called PVC. From there, one second. Hmm. From there, I'm going to create a pod with this one. So, and there are plenty of options and ways to bind these things that we will see in the next slide. Uh, so see, PV means like admin provided storage resource in the cluster. If it is my local, it is my local 500 my SSD. If it is in cloud, it is same like some EBS drive. EBS means elastic block storage. It is similar to the SSD that we request in cloud. That's the difference. So PV is considered the PV as your disk. PVC is just we get in some isolation. I want to like 1 GB. I'm requesting from this PV, and then the pods are get created from the PVC. Um, and there are different ways of accessing it there, like RWO, ROX, RVX. Don't consider it a very big thing. It's just an like I'm mounting an volume to the pod, right? So how the pod should access those data, that's the thing here. So read write once, that means if it is writed once, then it cannot be modify the data. Then read write many, and then read only many, that it is like read only. It cannot write the operation. It can only if some files are present in this PVC, how the way the pod is going to access it, whether it can read and write multiple times, or it should only read only, or like it read and write only once. So this is what this access modes are there. So this access modes will be seeing the PVC. So this is what the entire flow I was talking about. Like PV binds to PVC binds to the PV. The PV means like persistent volume, and then we bound the PVC to the pod. So let's start creating this one. So what I do is like I'm running in Minikube. What I in order to that, I'm going to my C drive. I'm going to make a I'm running in Minikube, so I have to provide this PV some allocation space. So what I do is like in my E drive, I create a folder called Minikube data. So I'm going to use this folder for this PV creation. Okay, I first before that, like let me mount this volume. Uh, my Minikube is already running in my cluster now. That's why I'm not running Minikube start command. I'm directly running Minikube mount, and E my Minikube folder that we going to create, and I'm going to mount it in the pod level. In the pod level, I'm going to mount it in the slash mount slash data. So we already know the first before colon whatever the directory you specify, it is on the physical host level. After the colon, whatever the directory I mentioned, it's on the pod level. So now I'm going to create it. Now you see what happened. Minikube mounting host E was into VM as MNT data. It started uh, successfully mounted. So this must for mount to be accessible. Okay. Now what I'm going to do is like I'm going to create the PV and PVCs. Let me go to my slides. I'm getting pv.yaml something, uh, and then I paste it. You see, still the declarative file looks like the same. The API version is v1, the kind is persistent volume, the name is like local-pv, the capacity storage is 1 GB. What I'm going to like, I'm going to create a persistent volume for 1 GB. So where this 1 GB is going to sit means this minikube data is there, right? So this minikube data, I'm going to reserve the space. So see if you check my E drive, I have still have like 235 GB free is there. In that, I'm going to reserve the data and minikube data like uh, like 1 GB. And we know like while I was running this minikube mount data, I mounted it on the folder, some folder called mount slash data. Let me run it in separate bash now. Um, mm. And then see the capacity I'm receiving is 1 GB, and then I want to access it like read write once. That means if a file is if I write some files into that, I cannot rewrite the file. That's the access mode is equal to read write once, and in the persistent volume reclaim policy is written. That means this volume even if you what we know is like we are mostly like delete the pods, right? After some pod work is done, we will delete, right? Even after the deletion, you want to retain the files or not. Then I specify that that's this persistent volume reclaim policy means it is like the mode is like retain, and the host name is host path is slash mount slash data. So now I'm going to create this one. I'm going to run the same command kubectl apply -f and pv dot yaml file. Wait, oh sorry, I didn't save the file. Uh, Now I saved the file. If you type kubectl get pv, now you see yeah, PV is created like the name is local-pv, the capacity is 1 GB, the access mode is equal to RW word, that means read write once, and the reclaim policy is written and it is available. Okay, you have to see the available status, that means it is not bounded to any of the pod now, still now. That's the meaning of this one. Now it's created. I will tell you some shortcut. You can set some alias because each and type I'm typing kubectl get what's or something, right? So alias means you are giving a pet name to it. Okay, consider like alias is like giving pet name. And what I do is like if it is like uh, if I type k, that k should be represent kubectl command. Okay, now if you see like I do k get uh, pv. Now you see the K represents kubectl. Once you refresh this system, you will not seeing this. Now one more thing I'm setting like one more alias is like kub kg I'm setting. Kg means kg is equal to kubectl uh, get kubectl get. Now I do so like what I do kg pv means you see kg means kubectl. I set it the kg means kubectl get. Then the full command is like kubectl get pv. So I'm just setting an alias. Now I'm going to create the pv from the pvc from this pv. What I do is like now I create one more file. I create like pvc.yaml and then go here and come back. Uh, Now I'm creating, yeah, see in the PVC also, still the template looks same. API version v1, kind is equal to persistent volume claim, metadata name is equal to my PVC, the access mode is equal to read write once. See, whatever the access mode you mention in the PVC, it should be there in the PV also. In PV, what is the access mode? It's read at one. Then if then only the mounting will happen. Then I'm requesting a storage of like I'm requesting storage like 500 M. 500 like 500 mi. What is 500 mi means half the gp. Okay, if it is like 1 gi means it is reserving some space, right? So 500 mi means like half a GB. Okay. Now I am going to do kubectl apply -f, and then I'm going to run pvc.yaml file. Now if you see kg pvc means uh, what it says now, my kg is like it's saying bounded. Now if you type kv now if you see the PVC, now it see my PVC is created and it is bounded to some volumes that we haven't specified, but here we haven't specified the volume, right? That's the reason it created its own PV and bounded to that. Now I reserved a space of 500 a year, and then the access mode is RW and the storage class is standard. So now my PVC is created. Now I'm going to create one more pod. I'm going to attach this volume to it. I'm typing like pod pvc.yaml file. Uh, uh, if I'm going back to my slide, uh, okay, I copy the pod section. See, in the pod template, everything remains same. You don't consider this busy box and all. This busy box is some image that mostly people use to some test applications. You don't consider that, but you see a section inside the pod special section. Previously, what we used to see, we will have these containers, we have this name, we have some this images alone. Now, now you see there is something called volumes I added. So this volume should be parallel to this container section, or it will throw you in like syntax issue. Okay, this volume, because this is container section. Okay, this is whatever you here you mentioned. This is completely a pod section. Okay, whatever in the container section you mention, if you mention inside this container, if it is like there are two spaces here, right? In after the containers word container, there are two sections, right? So whatever you mention the characteristics or arguments here, it belongs to the containers. So if you are mentioning it parallel to that container, that is belongs to this pod. We know we know I created a persistent volume claim, and the claim name is my PVC. If you see my PVC file, there you know I created a persistent volume claim name with my hyphen PVC. So I am mentioning in my pod.yaml in the first volume section, I am giving the persistent volume claim name as my PVC, and then I'm giving some name to it like my storage. Okay, so I'm creating giving a name as my storage, and the persistent volume name is like my PVC, and then inside the container I am doing the volume mount. So the whatever the data that generated like inside the slash data folder will automatically go to this my PVC. That's the meaning of this one. I mentioned my volume mount, and the name is my storage, where I mentioned it as my storage. In the outside of the container in the pod section, I mentioned the name as my storage, and then now it is going to attach. Now I am going to like kubectl um, get pods or something. Mm, kubectl, now you're going to apply hyphen pod hyphen pvc.yaml. So now a pod is created. What I'm going to do is like usually if the pod goes down and comes up, you will not see the data. Now what I do, I'm going inside the pod. What my pod name is, it's pvc user bash. Oh my god. It doesn't support the bash. Now I'm inside the container. If you see lsfnltr, I go to this slash data folder something, and I create some vi uh, .txt. Hmm. If you if you see my text.txt, what I did is like in the folder slash data, I create a file called test.txt. In that, I added the word allow world. Now what I do is like I exit from this container, and then I do is like kubectl delete pod, and then I give my pod name is pv hyphen user and delete the pod. Hmm. If I do kubectl, I have it's the pod is still in terminating state. It's not terminated. Hmm. It's deleted now. Now I'm going to recreate the pod because I stored some file, right? Now I'm going to recreate it. Now let me go. This PVC is bounded to my. It stored a physical volume. Now what I do, I go back to the pod again, and then I go into slash data folder. I should see the text.txt file. See. So that's the thing that it's similar to the same Docker volume mount what we have seen. Here we are like using PVCs and get bounded to pod. Um, I hope you got some knowledge about PV and PVCs. Let's move to the next section. So each what I told like when I was when we were creating this PV, it is an physical volume, right? It's a physical volume, and it you have to create this volume, right? Like whenever you feel like your application needs some space, and you think you are going to create some generate some files, and you have to save them in somewhere. You know that there is some storage that you have to provide, like where I told the PVs have some 500 GB of data, but what happens, you don't know that you don't want each and every time you create in some hard disk and create an PVC out of it, and you don't and create PVC from that. So you no need to do this manual work, right? So that is where this dynamic inventory comes. Dynamic means you don't need to do this PV adoptions no more. So what you have to do is like you have to create this storage classes. So mostly, what is this, the dynamic provisioning will avoid the use of this PV creation manually, because each and every time I have to attach some hard disk to my VMs and then create PV out of it and create PVCs and get attached to pod. So this is like a very big effect, because in the cloud nobody want to do some manual works day by day. So they, in order to automate this thing, this dynamic provisioning has came. So what is this dynamic provisioning mostly will do? So there are different CSI drivers are there. CSI drivers implements, like if you are using AWS, you will know in cloud we know lot of we have a lot of storage spaces there, right? So we will provide the permission of this EBS. EBS means Elastic Block Storage. It's kind of a service EC2 by gets that store like a C drive or D drive from the EBS only. Okay, we will create this dynamic inventory by using the storage classes, and while creating the PVC, we will just name the storage class name as standard. Okay, now what I will do, see, the storage accounts are used to create this volumes automatically. That is what this dynamic provisioning will be. Okay, uh, like because we don't know how the application is going to scale up. So on some particular on demand, if you want to create some new parts, and it has to request a storage from the store from the storage accounts or some EBS automatically, we can achieve that by using this dynamic provisioning. First I will enable this add-on in my local. um, this add-on I'm doing because I'm using mini Kubernetes. In cloud, you don't need to do these things. Uh, Now, what I do, I'm going to create a storage class. Now you see, still the templates look same. API version is equal to storage.k8s.io/v1. So this is what we call the API groups. Okay. So if you go for deployments, it is in different API group. It is in under like apps v1. If you go to Ingress, it is will be in networking.k8s.io. These are the different API groups that are available for you Kubernetes. That people will ask, tell me some like API groups. What is that API group means? Each are like some divisions in order to provision those Kubernetes resources. Kubernetes team has like division them so for their better improvements and for their team segregations. Okay, now if you see, go to my storage class.yaml file. I have to rename it. Wait. Now you see the API version is storage.kts.io. The kind is storage class. I'm giving the name as standard, and then I'm giving as professional as kubernetes.io no professional, because if it is in cloud the professional will be different. So like in cloud means the professional name for AWS will be like some like EBS, see EBS, let's see, like csi.aws.com. If it is like some NFS storage, NFS also like similar to a blob storage like nfs.ci.k.io. You just specify the driver names there. That's what we most like where you want to create the storage account. That's the meaning of this one. I'm giving it as no professional and waiting for and giving the volume bind mode as wait for first consumer. If any consumer started to use this storage account, it's get attached to this. So that's it. There is no reservation and anything is there. Wherever is a free space is there. When I provide this Kubernetes server, no provisioner, it takes my local and like whatever the limits are there, it will consume up to that. Now I'm going to do kubectl apply -f and then storage account now. Mm. Now if you see it is it's created. If you do kubectl get storage class. Now you see a default storage account with name standard has been created and it's keyed at AO and the minikey host path. So I have given is a no professional. So whatever in local whatever the professional is available, it took that. Okay. The volume bind mode is like immediate. That means waiting for the first consumer. That is what it's showing us like immediate here. So what I'm going to create now, instead of creating a PV, I'm going to create a PVC directly from the storage account. So whatever the limits available here, it will consume it. Okay. Now I'm going to create PVC sc.yaml file. Now you see, previously whatever we created, like it's similar to that, but here I'm just specifying the storage class name as standard. Previously we didn't specify the storage class name, right? If you see the PVC, the previous file, I just specified the access mode and the request limit. But now I'm going to specify the storage class name, whatever I'm going to use. I know it's the name is standard. That in that name only I created the storage class. Now I'm going to create that one now. kubectl apply -f pvc sc dot yaml file. Now if you type kubectl get pvc, now you see this dynamic PVC is now created. Diamond is bounded and it's created some volume with 1 GB it occupied. Okay, so that's how without creating PV, we are now by using storage accounts for dynamic provisioning of volume we created, and the similar thing in the pod section, like the pod-PVC, instead of this my PVC, you will be just mentioning the dynamic-PVC and bound it to it. It's same, the process is same, just you have to from which PVC you have to get the volume, you will just mention it that. So that's it about this dynamic, the PVCs and storage accounts and how you get bounded to the pod. So one more thing is that if you feel that let me uh, so now I'm going to create one more pod. wall.yaml file. Mm. So now, if you feel like your pod is going to, now we were see what we have seen, like we have seen PV, PVCs, and then this storage class, right? Now, similar to that, if you don't want to create these things like this PV or PVC or something, but you want to, wait one second. Uh, Instead of you create this PV and PVCs, you bound the data, you feel like my application is going to generate some data, but I some for temporarily really I have to store that file, but it is not mandatory for me to have this file even the pod goes down. Okay, if you have similar situations that like what you do is like you create this empty volumes. Okay, what I do. Now, what's the meaning of this thing means? So, see, this volumes actually in parallel to the container. That means this volume is going to created outside in the pod level. So, I created a cache dot volume and the type is empty directory. So, that thing means if you want a application to store some data, but it doesn't need like doesn't need even if the pod restarts or something, then you can use this volume. You just mention the volumes and you give some name, any random name, some with meaningful name you can give it, and you specify the empty directory, and inside that how I'm going to mount is we will do like volume mount, and then hyphen name is equal to hmm, hmm. This is how it's going to look. Okay, I have installed some extensions, that's why it's giving suggested. If you see this how the volume is going to look. So I'm created empty directory inside inside the container. I specify I created a volume like cache hyphen wall, and it is empty directory type. Inside the container, it's going to be mounted with the slash a folder. So if I try to create this thing, um, now see, one more pod is created for me now. So what does it means the empty directory I specified here. It is on the physical host level, and it is get created mounted on the slash a folder of the container. So this how the volume mounting, general volume mounting will be going to look if you don't want to persist the data. So there are two types. Either you can use this MD directory, or if you want to do some physical host path, that means while creating the Docker containers, we were seen, right? Like we create volumes and then mount. Even like that's possible here. Like you just instead of this one, you can create n number of volumes here. Like if you see, I added one more volume here. I am going to add one more. Uh, hmm. So this is how it's going to be. Either you can map some empty volumes to that, or you can like, hmm, or you can map some physical host path because you consider some in my physical host in my physical machine I have the slash directory. I want to mount it on the inside the container. I want to mount on host data. So even this kind of volume modes are possible. So we can do different types of volume modes. It's based on the necessity of the application, how we are going to map. So if I try to like kubectl, I try to replace it. If it don't work, I have to delete it. Pod dot hyphen wall. Hmm. Now you see, I created a pod now with two section. If you see like kubectl, I created kg pods. Uh, if you do like uh, kubectl get pod and then pod wall hyphen o YAML. I'm just wanted to see show you how it's got created here. You see, two outside there are two volumes are there. One is empty directory with cache volume. One is one more with host path, and it is created inside the containers in volume mounts, like in parallel to these containers. You see, it's parallel to the containers only. I have two volume sections here, and it got mounted inside the Docker container. So you can do different types of mountings as per your need now. So I so this is what the basic Kubernetes I want to cover. So mostly I have covered everything. The last thing would be for us to cover in this class would be like stateful sets. So similar to yesterday what I told, there are two type of applications. One is stateless and stateful. Stateless means like it is some web application or like front end, back end or whatever this thing. Because those applications will not like going to store the data. Okay, those applications in always what this front UI, there will be three-tier architecture, right? One is front end or we call it as UI. There's some second application will be back end. The last one is be database. So far we have seen these deployments and all, right. These deployments more are suitable to run this front end and back ends. Okay, but the front end back end it can be in different languages like Node.js. Like the front end mostly uses this React or Angular. The back end will be like Java, .NET, like Node.js, whatever it can be. So it those are like stateless. What this application is mostly going to do is like it receives some data. This backend is there, right? This UI is just to for you go to the browser, you see some web pages, some buttons and all, right? Those things will be in front end. This front end will calls to the backend where the processing actually occurs. If you receive some type, like if you receive some data, the backend will process it and save it in the database. So if we mostly we will not be running the database in the Kubernetes, but for in order to learn this, we are going to see the stateful sets. Mostly nobody runs the database as a Kubernetes pod. It's very so difficult to maintain the data in the pod level that by using the stateful sets. Still the database will be in separately in some of the PaaS services. PaaS services mean like a platform as a service. Like in cloud, in AWS, we have RDS, right? RDS means relational database. Okay, so we'll be using that only. But in order for you to learn this, I'm going to teach the stateful sets and how what is the stateful sets and all. Um, See, the stateful sets are suitable for databases like MySQL, PostgreSQL, MongoDB, and some message queuing services like Kafka, RabbitQ, and all. You ignore this. You just keep remember it. Stateful sets mostly be suitable for some databases. Okay. Like unless in the pod deployment, what will happen, like when I was talking about deployments, if I have like a deployment with v1 version, if suppose new pod is going to come up, what I told, the first pod will go down and the second pod will come up with the version v2, and the second pod will and the second pod will go down, and the second in the V2 version, the second pod is going to come up. This is what I told in the deployments. Whereas in the stateful sets, what will happen here is like, um, consider is my stateful set and it is a first pod. If second pod is going to come up, because this is stateful set, it will have some data inside it. Okay, in the stateful set, the first pod will is going to be consider it as a uh, it has some unique name as one. Okay, it has some unique name as pod one. Okay, if second pod is going to come up, it what it will do, it replicates the data from the pod one and creates the pod with the name pod 2, and we will have the data here. If it is going to create one more pod, the state pod is going to create from this pod 2 to replicate the data. This how this stateful sets rolling out will be going to look out, because it unless this deployments, it has to carry some data, right? So there should be some replication and synchronous things should happen, that will happen in the stateful sets. So here what will happen is, in the each and every pod, unless deployment, and what in when I was creating some deployment with Nginx, when you go, like, I think I still have there, if you go to kubectl. See, yesterday I was created a deployment with name Nginx. While the pod creation, you see, after these pods will be created from these deployments only. What happened here? There is a name called Nginx. After that, some random names are coming, right? But whereas in stateful sets, it not would be any random name. If you research, some other random name will come for pod. But whereas in stateful sets, the pod, each and every time, if this second pod goes up, and like if the third pod goes down and comes up, you will be seeing the same name for the third pod, because that's how the stateful sets work. Each and every pod gets a standard DNS name. It gets like some standard alias names. By using that name only, our application is going to access the stateful sets, because consider like Kubernetes pod, it is running with some backend application. If the stateful sets, this pod is going to access this database pod, right? The stateful states, consider it's going to access. If each and every time the new pod comes with a new name, means you cannot give that name in deployments. So that's the reason they came up with this idea. So each and every pod will always have a unique name in the stateful sets. So let's try. I hope you got it. So, and in order to let's cover first. Let's create the stateful sets first. I go to the KTS and then I create state stateful set dot YAML. See, this stateful dot YAML file also is going to look similar to um, if you see my stateful set file, you can see here, it is also similar to the uh, it is also similar to the deployments only. But what you see here, like, you see the same replica section here in deployment. So we have the replicas, we have the selector label here, we have the same pod template here. But apart from that, you see it has some environmental variables like hyphen name and values are there, and some volume mount is there. So this is the difference between the stateful states and the deployments. In deployments, we no need to store the data, right? Like even there is no like compulsory scenario. You can create with volume mount or you cannot create with volume, but stateful sets always create with the volume claim only. So here you see there is some template is called volume claim template is there. You just mention it as MySQL data, and it will read whatever the hardware storage is there, it will gets mounted there. Okay, this MySQL data is going to create it there. So, and it's this MySQL data is bounded to your pods as well, like inside the where lib MySQL folder. One second. Once again. Hello, hello, na? Yeah, I will come. I will come. I will come by like 4:30 or 4:45 something. Sure. Thank you. Mm, One second. Let's start the class. Um, So you see it's where I left. Except apart from deployment, here the volume section is mandatory for the stateful sets, and you have a special section here called volume client template. This section only comes only in the stateful sets. Here you mention the specification of your volume, what your access mode it should be, what's the storage sites that you needed, and then it gets mounted to the volumes. Now let me go and create the stateful sets. Apply fun stateful states.yaml file. Uh, 29. Oh, hmm, there's some template issue. Now it's corrupted. Now if you kubectl uh, get uh, state stateful sets. Now you see two pods are there. Like in the replica I mentioned as two, and it's coming up. If you see kubectl get pods, you see MySQL -01 because I given the metadata as MySQL. I given the stateful set name as MySQL. I given my name as MySQL, and the first pod is going to come up with MySQL-0. If you check for another pod, let's try to watch now. See, the first pod is created. After the first pod creation alone, when I was running initially, you were seeing the MySQL 0 only. You are not seeing the second one, right? See, but deployments will come up in parallel. First, the first pod MySQL hyphen is 0 is created. After some time, MySQL hyphen 1 is started to create. If you do kubectl get pods now you can see both the pods will be in running status. So that's how the data replication will happen between the stateful sets. Now, like the front end or back end applications that we deploy in the deployments, now by using these unique IDs, they can access this database store in the Kubernetes. So that's a thing about the stateful cells. And in order for you to, because if it is running in like 3 to 4 replicas, you will not be giving this name, right? This MySQL hyphen 01 hyphen 1 hyphen 2 or something. It will be tough for you to give a different pod in different address. So we know in deployments we will give the service. We'll give the service address to access the application. Similar to that, we are going to do the same thing, but here we are going to call that service as headless service because if you wait, if you see kubectl uh, get svc means you see it has some cluster IP, right? I have two services. One is this Kubernetes native service. One is like this nginx hyphen service which we created yesterday, and it got 10 cluster IP. But whereas in the case of stateful sets, it will not. I don't need this IP because by using this unique name which I have my for my pod, by using that only I'm going to create. If I create with the service with an IP address, each and every time if I recreate the service, um, this IP is going to get changed. So whatever, even for this nginx service, if I go to recreate this nginx service, it's going to give me some other cluster IP. Okay, this IP is going to keep on changing. So I don't want that. That's the reason I'm going to create something called headless service. So headless service are used for some if you want to access some application by using some common alias name or some DNS name, that's when you will be going to use the headless service. Now I am going to create some file called headless-service, an YAML file. uh, See in the headless file, this configuration is totally similar to this headless this service only. Only one thing is going to be there. The cluster IP is going to be none. That's it. The selector is something is there. If you see stateful sets which I created, I have given the selector match label is app MySQL, right? So but we know by using these labels only, the service is going to forward the traffic to the pods. In pod section, if you see, I have the metadata labels app MySQL, and I choose in the my match labels as app MySQL. By using this only, this headless service is going to capture the headless service. Also, I specified here the service name I specified. What is my service name? Is MySQL. So I created it, but I previously I didn't create the service. Now in the headless service, I am going to create the service with my MySQL and mention the cluster IP as none, because I don't want to have an IP because it's going to change. I'm going to access this MySQL service by using some DNS names. So now I'm going to do the ports are like 3306 and the target port is 3306. For MySQL, for any application, there will be some default ports. Like for Postgres, it will be like 5432. For MongoDB, it will be like 27017. For MySQL, it is like 3306. For Redis, it will be like 6382 something. Um, these port numbers for any database, there are some particular port numbers are there which will it's where the application is going to run. So if needed we can customize it, but mostly if it is MySQL, it is going to run in the port 3306. That's why we have mentioned the port and target port as 3306. Now I'm going to run this kubectl apply hyphen headless service something. If you see kubectl get svc, you see this time that MySQL service is created, but there is no IP is created for this. By using this MySQL, these applications going to the front end or back end applications going to access this database. Okay. uh, so I think that's it. We covered most of the Kubernetes topics that I want to cover. Um, so this how this front end and back end mappings will all happen. We'll be seeing this is a session for you to learn the Kubernetes basic steps and everything. We will have at last of our classes, we'll having a demo. We will what the demo was planned to create resources using infrastructure by using Terraform, and then you create a pipeline and then you deploy write some Kubernetes manifest. We will cover the entire flow with that, the original flow. But for this class, the particular scope of this class tool is learn the tools and resources that are available in Kubernetes. For now this is fine. So um, I covered most of the things. So one additional topic I want to cover today is like HPA. Okay. Let's ask. What is this? Yes, HPA means. Uh, we are going to go something called horizontal pod autoscaler. Uh, the basic thing about scaling, uh, because there will be an end user will be there, um, and some application is going to run, right? Some app is going to run. We are not sure how many users are going to eat my application. Sometimes it will be less, sometimes it will be high. Okay, the traffic will be keep on changing here. Okay, so we cannot sure like, but your application should be reliable to serve traffic to every users. No matter like it's like two users will be there, like thousand or million users will come tomorrow. So that's where the scaling comes. In general in cloud or in any platform, there are two types of scaling is possible. One is horizontal scaling, one is vertical scaling. In the horizontal scaling, what you do is like, you see, a single pod is running in horizontal pod, you consider it as running with one core CPU and 1 GB RAM. Okay, consider it is running a pod 1 running with one core CPU and 1 GB RAM. Okay, if the traffic comes in the horizontal bar scaling, what will happen? Another pod is going to create, consider it's a P2, and the same configuration, like it's going to run with one CPU core and 1 GB of RAM. Okay, this is called horizontal pod scaling. Consider like horizontal scaling or something. Okay, but whereas in vertical scaling, what will happen? We will have the same pod here, but one with 1 GB, one core and 1 GB of RAM. But in vertical scaling, we are not going to create one more pod in parallel. We are going to add resources here. What we'll do is like we will increase the resource limit of this pod to uh, two cores, two cores and 2 GB of RAM. The same pod will be, it will be like bigger pod. This is a vertical scaling, this is horizontal scaling. So mostly in the organization, vertical scaling nobody follows because it has its some issues are there. Everybody always follows the HPA scaling. When we came to Kubernetes itself, we were seeing the one of the important factor to move the application to Kubernetes is like scaling. When we were specifying the deployments, see, this is my deployment .yaml file. You just specify this is the replica count that I want. You specify 3, 2, 4, but you cannot wait until the customer comes, right? You want to somewhere some automation it should be there based on the traffic or based on the load. The scaling should happen. So in this HPA, the scaling is going to happen based on two factors. One is based on CPU and the second is based on memory. You can do if your pod gets like yeah, gets consumed like 70%, 75% of CPU, add one more pod. You write a condition for that. If memory it gets occupied like more than 75%, add one more pod. So that is what it is going to contain in the HPA section. So I type hpa.yaml file. Uh, I know my chat GPT would have generated me some files. I just copy that. Hmm. If you see this API version is auto scaling hyphen v2. The kind is horizontal pod auto scaler. The name is nginx hyphen hpa. This is some random name that you give it, and then the scaling target reference is equal to API version apps v1. Scaling target refer, that means what I am going to scale. I'm going to take scale some which is something on the API version apps v1. We know deployments will be in apps v1, and then you specify the kind which is deployment, and you just specify the deployment name here, and give the minimum replica and maximum replica, and give the utilization here. Like for what's the utilization threshold point, I have to scale. If you give this minimum replica as to, no matter what the how less is your traffic, always two pod is going to run. And then how like even like there will be like 1 million users in your application, it going to scale up to the 10 pods. Beyond that it will not be going to scale for you. You put some limits there. That's how the thing. So you mentioned the min replicas is 2, the max replica 10, and how the scaling should happen. Here I mentioned the metrics. The scaling is going to happen on the CPU, and the utilization is like 75 percentage. That's the meaning of this template in this template. So you don't worry about this template and syntax and all. You can refer and but you should know the general um, things how you to use Kubernetes resource. Now I know my deployment name is Nginx deployment. What I'm going to do, I'm going to spin up this HPA hpa.yaml file. uh, Now the HPA is created. If you use like kg HPA something, then you will be see the deployment is run. The two part minimum part is 2 and the max part is like 10. And currently it is trying to find the metrics. Okay, let's see, it is unknown. It will take some time, and we'll see what is the utilization there, and then it will scale up. If you see kubectl describe HPA, and the name is nginx hyphen HPA. Uh, mm, you see, it is trying to map the scrap the matrix. It's still not scrap. If you after seeing the matrix scrap, it will tell what is the average CPU percentage. The 75 percentage means this is an average one. Average means like if it is two bodies running, it will calculate the CPU utilizations and divided by two. If it is running by three means sum of some the CPU utilization of the three ports and divided by three. That is what is going to come here. It's taking some time to come here. So, but that is what the general HPA means. So, still there are like lot of advanced topics in the Kubernetes that I have actually mentioned in this slide. So you can see what we will just have a quick talk here. Um, because you should not be like unaware about these things like 0%. You should have something. So in Kubernetes, in the organizations, how they back up and back up this cluster. Mostly, it's Kubernetes cluster will be stateless. No matter if application goes down, we can just bring up. If there is a requirement in an organization for do some backups and in the DR, like if they want for DR, they want the backup, then there is something called Veliro backup is there. Nowadays in the cloud itself, they provide a native plugins for this backup and disaster recoveries. So now the Veliro backups in like Azure, it's available. You can like in cloud platforms it's available. If it's like taking how you take the backup of your Kubernetes cluster and then restore, because whatever the state currently it's running, like if you do kubectl get pods, you take this entire thing will be will be present in the backup file, and then once you restore, you will be seeing all the services, whatever was running in this cluster, it will be present in the new cluster as well. Disaster recovery means we will tell like we will be running one more like a server or instance parallel to production. If any issue happens to the production, we will be route the traffic to the DR region. So that you should be, these are advanced topics you can learn. And then there is something called upgrading Kubernetes version. Today, the Kubernetes version that as of now what we talk, the Kubernetes recent version is like 1.32. Okay, but tomorrow if there is new version is upgrade, like it's moved from 1.32 to like 1.33, you and your organization decide this is fixed, and your organization decided to upgrade the version to 1 by 33. And these things are actually this upgrading the version from Kubernetes 1.32 to 33. These options are now available in the cloud. You have to request a downtime from your team, and then you will be like draining the node, the draining instance. There will be no pods will be running in your Kubernetes. You make there will be some option there. So no pod should be you when you click the draining, whatever the pods scheduled in the worker nodes will go out, and then you make the complete node empty, and and then you choose the cordon option. Cordon means the node is it got evicted. No pods are scheduled. If you do cordon, no more pods will come to that node. That's the meaning of this cordon. And then you upgrade your Kubernetes versions. And then we were seeing this HPA scaling based on CPU and memory, and something is SCADA is there, event driven. This is Kubernetes event driven auto scaling. In the real world situation, what will happen here? Mostly, we will be scaling the application based on CPU and memory, but mostly in the real world scenarios, your scaling doesn't depend upon the CPU and memory. It based upon the network traffic, because now many people said like 1 million users comes means you have to scale the application according to that. For that only something there is some plugin called SCADA is available. It's kind of an it will be by using SCADA you can do some scaling on custom metrics apart from CPU and memory. You can do based on some events, like there is 1 million like 1 million events that like 1 million event means 1 million messages if client sends. Based on that, this many part has to run. You have to set by using those custom metrics, the CADA can help for you. And something called network policy is there. We were talking about namespaces, right? In a cluster, two namespace will be there. If a pod running in this namespace that do not have need to be have access here, then you have to apply this network policies, and something called pod securities to pod security admissions to scan your images. You will be using Trivi. Trivi means like you created a Docker image, right? This image is good or not. That is what we are going to scan with Trivi. Okay, it will, because when we were doing sonar scan, it will scan only uh, the code quality, but whereas it comes to image, it it actually scans your code as well as the libraries and system files that present in the image, because the Docker image is going to present everything, right? The system library files. By using Privy only, we'll be going to scan this. And then Elm packages, we'll be seeing the Elm in the next classes. So you know, no need to worry about this thing, because whatever the template, whatever we are written, nobody is going to write this template as it is. By using the Elm package manager only, they are going to write it. That we will be seeing in the next class. And some Kubernetes cluster troubleshootings and all will be there. Troubleshooting means if pod is not running, what they will ask you, if your pod is not running, in the interviews they will ask, how do you check it? How do you verify? You tell kubectl get pods, you check the status, and then you describe it, and then you check this phone. If it is like binding, you should check for why, whether the volume is present or not. So these things you will be learn once you started to working on. You cannot directly tell that you have to do these things. This basic troubleshooting they will ask. And taint and tolerations. What is this taint and tolerations means, like uh, mm, consider there are like two worker nodes are there. Okay, I think I covered in the first class itself. So if a pod is there, yeah, pod 1 is there, and it is worker node and v1 and v2. You make some special document that pod p1 should go only to the like a worker node 1, not it's not go to the v2. This is controlled by this taint and tolerations. There's something called taint and toleration, node selector, node affinity. So these things are used to control these characteristics what I mentioned here. So and then some operators are there. So what is this CRD means, like custom resource definition. So I have created some resource called deployment, right? These are Kubernetes own resources. If you want to create similar to this deployment, if you want to create some other resources, uh, that you have to use the CRDs, that is called custom resource definitions and operators. By using this custom resource definition and operators only, like in Kubernetes cluster, lot of plugins are going to be added. Like Elm is going to be added. On top of Elm, we are going to add Argo CD, we are going to add Prometheus, Grafana and all, right? Those things and all, by using this plugins only it's going to run. And some webhooks are there. Webhooks like validating and mutating webhooks. So when we were initially creating some deployments, when I was doing kubectl get, you see, when I was see when I want to see the pod YAML file, pod dot wall. You see only these characteristics I mentioned, right? Pod wall, but where these other characteristics are comes, like you see where is this namespace came. I didn't specify the namespace here, right? The best example would be namespace. When I was kubectl get pod wall hyphen o YAML. When I was checking this YAML file, this the YAML file which I have here, I didn't specify the namespace, but whereas this namespace came from. This is where this validating and mutating webhooks tools. Validating means if this syntax, if there is any syntax issue or any issues in these um, in this file, that that is validated by this validating webhooks. Mutating webhooks means this is what going to add the namespace default to your YAML file. Once the pod is created, this what these characters are added by default. That is what controlled by this mutating webhooks. Whatever I told in the last 10 minutes, you don't need to like have complete idea about this thing. But before you, but and similar to that, you should not be unaware about these things. You should be at least aware about these things. If somebody asks about it, you should be capable to tell one or few words about these things. That's the reason I have explained all these things. At the end of this recording, you can see what are the topics I covered. If you wanted, you can learn about these extra topics, or in our class itself, you want me to teach, I can teach it if we after completing all our other courses, because Kubernetes is very vast topic. Nobody can make it complete in like 3 or 4 classes itself. So I think we completed Kubernetes. Like we and in top of Kubernetes, we are going to go do some other stuffs in tomorrow's class that we will going to see. Any doubts for you?